All right, welcome back to Math 155, 14.4 to 14.5 integrated review. So this is our last video on 14.4 to 14.5, talking about multiplication of polynomials, specifically multiplying two binomials. So binomial means polynomial that consists of two terms. Okay, so we're gonna take two binomials and multiply them together using a technique called the FOIL methods. So before we multiplying, I want to go back and talk quickly about again the difference between x plus x versus x times x. So x times x is one term. So multiplication between anything is only one term. So when it comes to multiplication with the same base, we can simply add the exponent. So 1x times 1x is 1x, right? But we also got to add the exponent, so my answer got to be 1x squared, or simply say x squared. But when I'm combining terms, 1x plus 1 more x should give me 2x. Why not x squared here? Because I'm not multiplying, okay? So I don't think about adding the exponents, okay? So be very careful. Got to know when you are multiplying versus you are combining. All right, so let's give this a try. I wrote this particular example down twice so I can explain to you what the FOIL method means. FOIL method, some of y'all may remember, F means first, O means outer, I means inner, L means less. So this four letters right here, okay, FOIL, comes from the idea of distribution, but distributing multiple times, let me kind of show you like this. Imagine this x plus 7 times x plus 5 where there's no plus 7. When you only see this x right here times x plus 5, our first natural instinct is do a distribution. Okay, so that will be x times the x plus 5. So now let's take a look at what happened if the plus 7, the x is not there. So if the problem look like this, then I'm going to use my 7 or positive 7 to do a distribution. Okay, so when I use my positive 7 to multiply the same x plus 5, okay, and since I already wrote the same thing up front using the x, that means I'm actually doing distribution multiple times. So when I'm looking at this problem, in this particular fashion, then the very first thing I do is simply say x times x. So the FOIL method, having two term times two term, the first thing I do is x times x, which will give me x squared, right? At 1x times 1x, x squared. When I multiply the variable, I got to add the exponents. Then the next thing I do is x times positive 5. So when I say x times positive 5, that will be outer. Two outside numbers multiplied together, which will be positive 5x. All right, I stand for inner, because the next thing I do is taking positive 7 times x, which in the FOIL method, positive 7 times x will be my inner. So positive 7 times x is positive 7x. So now the very last thing I do is saying positive 7 times positive 5. Positive 7 times positive 5, the very last thing I do, okay, that will give me positive 35. Be very careful now, we are multiplying, so you constantly have to tell yourself I'm multiplying, so you're not going to accidentally say 7 plus 5, which is 12. Okay, that will be incorrect. So now the only thing I can do is combine like terms. So these two terms in the middle are like terms. So I can combine them. So that will be x squared plus 12x plus 35. So the idea of a FOIL method is basically doing distribution twice, okay, multiple times. All right, let's try a few more. All right, remember now, the very first thing I do is take the first term, so take my x to do the distribution. So x times 5x, 5x squared, right? X times x squared, add the exponent. X times positive 6, positive 6x, that's outer. Now my inner, negative 2 times 5x, negative 2x, excuse me, negative 10x. Then we say negative 2 times positive 6. So that will naturally be negative 12. So now when I combine like terms, again, 6x and negative 10x can be combined. That will give me negative 4x. And my last term, negative 12. All right. Both of them are positive. In this example, let's give it a try, okay? First thing I do, 4x times 6x. 4x times 2x, excuse me. 4x times 2x. 4 times 2 is 8. X times x is x squared. So that would be ax squared. 4x times positive 4, which is positive 16x. All right, inner, positive 1 times 2x, positive 2x. And the last thing I do, positive 1 times positive 4 is positive 4. All right, so when I combine like terms, that would be ax squared plus 18x plus 4. All right. Now this example is where we can add another variable. Okay, still a polynomial, just adding another variable right behind it on the second term. Okay, but we still do it the same way. As long as I have 2 terms times 2 terms, I can always use FOIL methods. So 5x times 5x, first thing I do, 5x times 5x, 5x squared, right? Multiply the coefficient, add the exponent. All right, then the outer, 5x times positive y, 5x times y, positive 5xy. All right, my inner, 2y times x, 2y times x means 2yx. But multiplication has commutative properties. So 2yx can also be written as 2xy. We normally go by alphabetical and exponents. You probably remember me mentioning something like that before. And the reason why I mentioned that before is for polynomials. Okay, so we go by alphabetical order. That's why normally x go before the y. So 2y times x is 2xy. The last thing I do is 2y times positive y, which will give me positive 2y squared. Okay, so this is very strange. This is a very strange answer. The two like terms are 5xy and 2xy. So 5x squared is still the same. 5xy plus 2xy is 7xy. And my last term need to be 2y squared. And this is the reason why. Alphabetical and go by the exponent. X go before y. All right, so if you think about the exponent on top of the x, 2 power first, then 1 power, and then no power for x to the 0 power. So the x is going in a descending order on the exponent. Now the y need to be go in order in ascending order. So the very first term is y to the 0 power. So that's 0, 1, 2 power. So it go in order, but because if I say 5x squared and then 2y squared and then 7xy, okay, that means the exponent for the x, okay, think about this. The exponent for the x now reads 2, 0, because the second term had no x in it, and then first power. So that's not in any sort of order. The exponent for the y, see the first term has no y because it's y to the 0. So the exponent for the y will now read 0, 2, 1. Okay, so that's not in order. That's the reason why we have to write x squared up front and y squared on the back. The first power goes in the middle. All right. So in this lecture video, we talk about how to multiply two terms. Okay, multiply by two binomials. Okay, using FOIL methods. Binomial means two term times two terms. Every time we see two term times two terms, we can use this technique called the FOIL method. All right, that will conclude this lecture video, and that will also conclude our test 1 material as well. Thank you for watching.